All right, today we're going to be looking at solving equations where there are variables on both sides when we're starting out, okay? And the trick, or the tip I have for you is to really think ahead about which side it will be easier to have your unknown on and end up on. It doesn't matter. X could end up on the left or the right. It doesn't matter. You could have your answer equals X, or you could have X equals your answer. Those are the same, okay? So let's do an example. We have this equation right here, 3x minus 2 equals 5x plus 16. And I can see that I have more x's on the right, so let's keep my x's over on the right. And to do that, or let's accumulate x's on the right. Let's group them together on the right. So to do that, I am going to subtract my 3x from the left side. These guys cancel. We are left with a negative 2, and we have a 2x plus 16. As you get better at this, one thing I could have done initially is also subtracted the 16 from the right side as well. And so you're essentially doing two things at the same time. But as you're getting started, it's probably easiest to separate those steps out. But we can do that now. We can subtract the 16 from both sides. So again, it looks like we're trying to get our x's on the right and our numbers on the left. We're left with a 2x on the right side. Negative 2 minus 16 is negative 18. And as our last step, we can divide this guy by 2. And it looks like we have a negative 9 equals x, and that's our solution. Okay, so if you did choose to do it, follow a different pathway, you could have subtracted 5x from both sides first, and you would get the same solution, the same answer. You're dealing a little bit more with negatives. That might lead to a mistake, although it's certainly good to practice dealing with negatives. Next one involves the distributive property. I did a video earlier where I showed that in some cases you don't need to divide or you don't need to do the distributive property. You could divide, in this case maybe divide by the 4. But in this particular case that would complicate things because it looks like we have a potential distributive property on both sides. So if we divided 3 by the 4, we would have a 3/4 on the right, and that would get a little bit complicated. So let's do the distributive property now. And as a reminder, we're going to take each of these values and distribute them through the parentheses. We have a 4x minus 32 plus 5 equals 3x plus 6. And last little bit of simplifying, 4x minus 27, we're going to combine those terms together, equals 3x plus 6. Once again, let's figure out which is the easiest side to end up with our x's on. I have more x's on the left, so let's subtract 3x from both sides. And we're left with a 6 on the right, and we have an x minus 27 on the left. Adding 27 to both sides, we have x is equal to 33 as my final answer. I'm going to model a formal check for this guy. Let's say, and I'm going to do part of it in my head as we go. 33 minus 8 is 25. So let's see if 33 is the correct answer. Plus 5, is that equal to 3 times 33 plus 2, 35. So this is 105 on the left, and that does equal 105 on the right. So it looks like we got it. We got it correct. X is equal to 33. A couple special cases I want to show you, and we'll go through them each before I tell you what identities and no solutions are, although you might be able to figure out what those mean. But these are some special cases that you'll encounter at some times. And I'm going to go through all the complete process on each one, but then I'll talk about how we could have seen what the special case was a little bit earlier in the process. But regardless, I'm going to go through the whole process on each. Let's do this, the distributive property. We have a 3x minus 6 minus 4 equals x plus 2x minus 10. So it's a 3x minus 10 equals, on the right, we have a 3x minus 10. We can add 10 to both sides. 3x equals 3x. And then divide both sides by 3, and we have an x equals x. Well, of course, x is, of course, equal to x. This is called an identity. Okay? This is a guaranteed equality no matter what x is equal to. X could be anything. X could be any real number, and we will have a valid true statement. And we could have identified that way back up here, or maybe even earlier. If you ever just get identical statements on the left and right side of an equal sign, you're dealing with an identity. Okay, so this is an identity. The solution is all real numbers. Okay, x can be anything. At this point, by the way, you might be thinking, what the heck is a real number? Are there any numbers that aren't real? And yes, there are. There are numbers called complex numbers, portions of which are referred to as imaginary numbers, but we'll get there probably in Algebra 2. But x can be any real number in this case. By the way, from this statement right here as well, we could have subtracted 3x from both sides and get negative 10 is equal to negative 10. Another legitimate concluding point to realize that that we have an identity and that x can be any real number. Okay, so that's one special case. Another special case is over here. We will work through that one. We have a 5x. Let's distribute. 3x minus 6 equals 8x plus 40. I think you can probably tell that we might be dealing with a no solution here based on the heading of this example. We have an 8x minus 6 equals 8x plus 40. And let's see, let's subtract 8x from both sides, and we have a negative 6 is equal to 40. What the heck? What the heck's going on with that? Negative 6 is never equal to 40. Okay, no matter what x is, no matter what value of x you plug in for x here, you will never get a valid equation because negative 6 is certainly not equal to 40. So that's certainly something that you want to pay attention to, but it's a curiosity, it's a special case, and there are no solutions here. You might have realized that back up here. It's similar to this one over there. We have the same numbers of x's on each side of our equal sign, but in this case we have a different numerical piece on each side of the equal sign. So if we subtract those x's away, which is what we did, we get an impossibility. So no solutions. And that's a good place to stop right there.